Okay, I can see here that some of your group still not yet finished. Group 1, question number 4. Okay, for those who just like need to upload your like picture, or you need to like finish a few question, please proceed. And I'm going to start first while waiting for you to try to finish your Jamboard. I'm going to recap a bit. So starting from now, please make sure don't WhatsApp, don't comment. If you want to interrupt me, please, as usual, just open your microphone and start enable your webcam. Whenever like I stop and I check you did not enable your webcam, you're going to be asked as usual. So let's start our class because we need to like speed up our module 2. And the question basically that I share with all of you just now, I take on previous past year for test 1. And there is also question coming out from retest, but it is all from test 1. So if you can like successfully answer everything with ease and no need for you to like refer back to the notes, then you are ready to take test 1. So that is a kind of question that been asked, and mostly the question is basically Q&A, multiple choice, which is going to provide you with answer, but it's just like copy paste and I need you to like show the step. That's why I just made like that. I will check your answer later on after this, because the answer is already there in the test past year. So it is not difficulty for me. Only that just now I just copy paste. That's why I didn't realize about the base 10, right? Eh, why my pen did not detect? Wait, pen cucuk je. Okay. So about the best 10, so I forgot to put it. I just like copy paste without rechecking back. Okay, now back to our reality, which is on our module 2. Still in our module 2 last week, we already looked into binary. This one is fraction, no, the whole numbers, conversion. Okay, this one also already done. Okay, we need to look into binary fraction to octal and hexa conversion. Is it we are until here, right? Last week. So what we need to do if we want to convert to octal from binary to octal, but it is under fraction number. I guess the rule we already finished. I think not yet. We just convert binary to octal first, and then hexa we did not yet cover. Okay, last week we until here. Under example number 2, first if we want to convert from binary, which is our base 2, to base 8, we need to look into the LSB. For the LSB, we need to separate every 3 bits, 3 digits starting from LSB. You cannot start with your MSB. So please make sure if you want to convert for the integer or the whole number, then you need to start with your LSP and divide it into 3. And after that, you're going to see it's like a normal conversions for binary to to octal, or maybe over here it's going to be on decimal. So when you convert over here, you will get 4 to 6. This one is 1, 2, 3. This one is 2. And then you're going to go to octal. So is it true or not? You can see. So this is how you directly convert from 10011001110. So you can directly convert to your octal or base 8. This one is base 2. And after that, you need to convert directly binary to hexadecimal. For hexadecimal, you convert 2 to 16. That's why you need to divide it into 4. Why it 4? Because 16 is to the power of 4. And just now we learned to convert to 8. We need to divide into 3 because it is to the power of 3, which is you need to spread into 3. And still, because it is integer and it's also a whole number, we're going to start from LSB. So we will going to divide it. This one is basically just a recap because we did last week. And over here we will get it for 2. I hope no need for me to show back what it is like to the power of 0, to the power of 1, to the power of 2, to the power of 3, because this one we already looked into several times. So I hope that you know why I just do it and convert it directly. So I get over here 14, isn't it? 8, 12, 13, 14, 14, it will be A, B, C, D, E. Is it E? And then over here, why is E? Please make sure also this is hexadecimal. Normally you're going to get 14, but there is no representations on 14 for hexadecimal. That's why you need to convert to representation for 14 is will be E. And similar to the rest, you're going to see over here also you will get 8 plus 4, you will get 12. 12 in hexadecimal it will be C, and this part is 4. So direct convert for this long binary number, you want to convert to hexadecimal, you will get 4CE base 16, and then this is base 2. So this is how you convert. And last week also you already looked into decimal to convert to base 2 for 8, 16. Basically 4 also can, which is any base. We already learned how to convert decimal to any base. And if you look over here in this part, it's quite easy because there is only one method. Either it is for integer or it is for fraction number, you just apply similar method. But if you want to convert any base to decimal, which is our base 10, what happened? You need to have two methods. If you still remember, you have two methods because for decimal, you're going for integer, you're going to do the I forgot already the name. The method that you need to divide. Continue, divide. The name is what? Help me with this.
Successive
Ah,
successive division.
Yeah, successive division. You need to repeat doing the divisions. And for the fraction, you're going to do the successive multiplication, right? So you need to multiply. So if let's say your numbers include these two both, which is integer, let's say 197.197. So you have two part, then you need to apply these two methods. So for any base to decimal, you need to see there is two method for you to remember. So it's like slightly difficult if you compare when you want to convert the decimal to binary, any number base. Now, last week also we already looked into how you're going to convert this kind of number, which is binary to octal, binary to hexadecimal. So I guess it's easy for you to memorize and to get to know on it. This is the new things, which is you just want to learn on this today. We're going to look into binary fraction to octal and hexa conversion. Uh, I guess last week also I just touched a little bit on this part, which is it's slightly different because for integer, we're going to look into like from left to the right. We start on our LSB. But under grouping is still similar, which is if you want to convert to octal, we're going to separate it into 3 bits. But for hexadecimal, we're going to separate it into 4 bits. And it will start counting from the radix point, which is our fractions. We start to the right. This is just the only differentiation between this. And you need to remember, you need to add 0 if there is nothing on the right side. Okay, let me see. Let me show you for this integer part. No need for you to add anything on your right side, which is your LSP, because if you just adding like this one, or if you just adding, if you have 1101110, let's say you want to convert from binary to octal, so you divide it into 3. And if you like already know, okay, decimal is okay for you, you know that this one is 3. But to avoid any confusion, you can just put 0 in front just to make it as a 3 digits or 3 bits. Different with the fraction, where you need to apply the 0 is at the back, which is this one is on your MSB for the integer. And for the fraction, you need to add at the LSB or the right side. Let's go back to the slide. Okay. Where is it? Okay. That's why you need to add the necessary number of 0 bits to the left LSB side. For the whole and fraction binary, the process is divided into 2 steps if you have these two numbers. First step, you need to group the whole integer part portion starting from radix and move to the left. This one you already done, it's easy for you. And add the necessary number 0 to the left. As I mentioned, it is not needed for you basically to add 0 if you already master with like binary and there is no any confusion for you. But if let's say you want to avoid any confusions or maybe to avoid any mistake while you convert, because sometimes it's going to be confused for you. 11, is it 110 or what? So that's why it's asked you to add 0 in front, so that you know, Okay, this is 3 bits. While for fraction number, you need to group fraction portion starting from your radix point to move to your right side and add necessary number 0 to the right. This one, I guess this is much more important, because for this part, I guess as we usually know our numbering system, if we have 1 we will know that this is LSB. Supposedly this is to the power of 0 to the power of 1 and etc. So that's why there will be a number in front. Same goes to our numbering system. Let's say we have 221. If 21 decimal, of course, in front, all there is a value of 0, which is nothing here. But if you are playing around with the fraction, if you forgot to put 0, then you're going to have a very high chances for you to get the answer wrong. Let's say after our fraction is like this. So if you want to convert 2 to 8, you're going to divide it from here, right? From your radix point to the right. So this is the first one. And the second one, this is the one that I mentioned. You will have a high chances for you to get it wrong. Because this one, you know that this will be 415. And this one, normally we just assume, okay, 01 will be 1. But it is not. Because this is a fraction number, it's supposedly there is something over here. It is not 0, 1, 0. Because if you put and assume it as P1, so then there is 0 in front. But because it is a 0, 1, you need to know it will be 0 at the back side. At the right, and there is a left for the whole. For the fraction, you need to add the right. So this one, I think, because all of you like clever student, I guess no need for you, and it might not confusing you and things. But if you play around with fraction, you must put this to avoid your confusions and also to get the very correct answer. Because when you are in the like test, of course, you get the pressure with the time, and it will like make you a possibilities or high chances for you to forget everything, and there will be a careless and silly mistake that you can do. So please remember the second step. And there is an example over here on the wolf fraction. Again, if you have like any problem, just ask me and interrupt me, okay? Okay, over here you can see example number 3. We have two numbers, which is first is our integer and another one is our fraction number. So we need to separate it. First of all, let's say you have this, you need to spread it similar to when you want to convert the decimal, any base number to decimal, right? If you want to convert, you need to separate it together like this. And this part, what and how you're going to do is from the left to the right. And for your fraction, you're going to do the from the left to the right. And what you need to remember, you need to put 0 at the back of the right side. And here will be 0 for the left side. And maybe you can take this and group it into 3 because you want to convert it into octal. Here you will group 3 and 3. And please see, this is the first one, and then second, and third. Going to see that it's add up 0 in front just to avoid the confusions over here. And the value you can directly convert. I hope that it is easy for you, no need for me to explain in deep. And for the fraction, you're going to start from the left side. You need to divide it into 3 bits. See, now you divide this one to be here, this will be here, and this part will be here. So you need to add up 0, 0, just to make it complete as 3 bits. If let's say you want to convert to octal, maybe you need to put like 3. If, okay, just this one, if let's say it's complete 444, but you just left one over here, you need to add another 0, 0, 0 just to make it complete 4 bit. Because if you just like add 3, it's not enough because you're going to make it like 8 instead of 16. 16. 16. So please make sure you see how 16 or 15. Please make sure that don't forget for you to put 0, 0. Same goes to here. If you think that it might confuse you, if let's say you have only 1 here, you need to add 2, 0, 0 for convert to 8. So you can see there is an answer for you also regarding this example. And yeah, as mentioned, it's not hard at all. It's supposedly quite easy. There is another example, but this example is needed for you to convert from binary to hexadecimal, which is you need to divide with 4. Now you can see you have also 2 part number, the integer part and also the fraction part. Then you divide it into 4. 1, 2, 3, 4. Okay, this one is enough, everything. And this part, starting from your ready point, going to add another 0 in front. So it's just a similar things. What you need to do, then you convert it. And don't forget, if you play around with hexadecimal, when you have numbers 10 and above, starting from 10, you're going to convert to BA, 11, B, 12, C, 13, D, 14, E, and 15 will be F. So please make sure you remember this. Until up here, is there any question? Okay, if there is no question, let we proceed to octal to hexa, octal and hexa to binary conversion directly. So just now we learned binary to octal and also binary to hexa for the integer and also the fraction number. But now we're going to learn octal to binary, hexa to binary. And we're going to do like a vice versa thing, convert every bits into group of binary bits, which is, if let's say octal similar, we're going to put it as 3 bits, and hexadecimal is 4 bits. When converting octal to hexadecimal, and vice versa, it is advisable to use binary representation as intermediate conversation. This one is later on. Let me see the first step when you have, give you example, let's say for octal, okay? For octal number, let's say you have 5, 3 base 8. You want to convert directly to be a binary. So these two number, every digit, you're going to separate it first. And these three, what you need to do, you direct convert 3 to binary, you're going to get a value of 0, 1, 1. Don't forget to put this 0 because you cannot just put 1, 1. Although you know 1, 1 plus 2 equal to 3. Oh, this one is base 8, sorry. For base 8 is also similar. Okay, now you can see over here, although it's also similar, because the value is 3 in decimal also. I just give you example first, okay? But don't forget to put 0 in front. Similar to, let's say you, because if let's say you can like convert it later on after this, 4, 5. Let's say you after this you convert, you will get 101. If let's say you didn't put any zero in front, you will get something like this. But this is not the answer because you forgot to put 0 in front. As I mentioned, you need to have 3 bits for octal and 4 bit for binary. You need to complete it to be, this is 3 bits, this is also 3 bits, and you combine it together to be one binary number. Okay, this is the example. Kenapa tak ada octal dulu? Or it's direct for hexadecimal first. Let me go for, no, here. Okay. Let me see. Now you can see we need to convert to 4 digit. Hey. We have 7 B A. This one is 4 2 1. And because of we want to convert from hexadecimal, we're going to separate it to be 4 digit later on. And let me see one by one. For 7, if we convert it into binary, we will get 1, 1, 1. But as mentioned, we need to make it full 4 digit. We need to put 0 in front. See here. Then B. B is what? In decimal, B is 11. So 11, how you're going to represent in binary? You're going to get 8 plus 1, plus 2 plus 1, 10, 11. So you get complete like this, you put here. And for A, you will get 10. 10 will be 0, 1, 0, 0, 1, 0, 1, 0. This one is 8, this one is 2. You add, you will get 10. And 4, you will get 0, 1, 0, 0. 2, you will get 0, 0, 1, 0. And 1 will be 0, 0, 0, 1. And this is your ready. Then you combine it all together here. Don't forget, you can see you will have 0 at here. Similar if let's say this is, but for hexadecimal there is no AB. For octal, you're going to have no A and B because you have only 0 until 7 representation for octal. And as I mentioned, if let's say you have 5, 7 octal, you want to convert to 2 binary base 2. You just need to divide it also to be 101 1, 1, 1. It is lucky for you if let's say it's directly have 3 digits, 2 bits like this, because you just need to combine together. There is no like confuse at all. But if you'll have something like this number 21 21, it is not 21, sorry, 21 octal, you want to convert to base 2. What is the answer? So what you need to do, you need to convert first 1 to be in binary. It will be 1 0 0. Why you need 0 0 in front? Because you need 3 bits as a representation. And for 2, you're going to get 1 0, and you need to add 0 in front. Let's say you have another one which is 3. You will convert 0 1 1. Then the total answer, if you want to convert 3 to 1, add, you will get 0 1 1. If you don't put 0 also, it's okay. If for final answer only, for the MSB part. But for inside this one, you cannot delete it. So if you are, I'm afraid if I do mistake, so just put 0. Everything's over here. And you need add on like this. So this is the answer. If you just put 1, although it is correct, the value when you convert one step, but when you want to convert and combine it together, your answer will be like 0 1 1 0 1 0 1. So this is totally wrong, and when you use your calculator also, you will get the different answer. That's why you need to make sure carefully you have these 3 bits, 3 bits, 3 bits for octal. If you are playing around with hexadecimal, you need to add, you need to make sure it's to be 4 bits while you have converted. At the back of at the below part here, for example, to now you have octal to binary. For octal to binary, as I mentioned, you're going to convert and put it one by one like this also. And don't forget that if you have 1 1 over here, if it is not complete 3 bits, you need to add on another 0 in front. Same goes to here, you need to add on 0. This part also you need to add on 0, and you just combine it together, your answer. So it's quite easy. It's not like too complicated for you to convert from hexadecimal and also octal to binary. As long as you need to also know that you need to separate it into integer and also fraction part. So that is exercise. You need to convert like these numbers. Maybe you can try it by your own. And this is the answer for you to refer. And last week, is it Khalid inform us and teach us how to convert the is it the reminder? I forgot who's teachers using calculator. If you have like this fraction, is it for you can use calculator to convert? Because another section, which is section 6 or section 9, asked me how to convert fraction number inside your calculator. If you can do it, then it's okay for you to just check the answer. So you can like directly convert. But also, I suggest you to learn using the step, because sometimes for your part A, you need for part B, you need to show the step. And this is like a summarization for all the number system conversion. If you have like decimal and then you have the whole and fraction, you're going to have octal, binary, and hexadecimal. If you want to convert to here, what is the method you're going to apply? For the whole number, if you want to convert from decimal to hexadecimal, or although also a binary and octal, for the whole number, you're going to use the successive divisions. And there is also example showing here how you're going to apply the methods. And between all of these also, if you want to convert binary to octal, how you're going to do. If you want to convert octal to binary, what you need to do. Similar to binary and also hexadecimal vice versa. So you can make this slide as the conclusion and for you to remember. So only that for 2.1. Let me open another notes which is 2.2. So is there any question until up here? I think it's quite easy for you to remember if you do many time on exercise and play around with the numbers. Where is my digital logic? Okay, here. Oops. For those who still did not like receive your module books or ebooks, please WhatsApp me because I think they already like post out and many of you already received the module book hard copy. But for ebook, everyone already get. So if you still did not get ebooks and the hard copy, please WhatsApp me personally, okay? To be. Okay, now we're going to move to data or organizations code for our module 2B. Okay, just yesterday. Yesterday I teach Space KL part-time student for COA subject, which is the subject that you going to take next semester. So they need to learn about this bag, which is nibble by words. So please make sure if let's say you want to score until the rest of your semester in university, the basic subject which is like digital logic or whatever subject you take this first semester, you need to score and remember because you're going to apply it. Although you're going to have like a recap later on before you start going deeper in your specific subject, but it's best for you to have the knowledge before you start the subject. So this one just yesterday I teach for COA subject again to do a recap. So over here you need to know a common collection of single bit. You're going to have the smallest one we call as bit, the one that 1, 0, 1, 1. This is bit. That's why like we divide it into 3 bits, we divide it into 4 bits. It's called a bit. And if you have the 1011101010. If let's say we have the group of 4 over here, these 4 we call is as nibbles. We call it as nibble. And if 8 bits, we call it as a byte. This one. So this thing is not only important for COA subject, for digital logic subject, but if you play around with networking later on, you have a header table, everything you're going to apply this thing, bit, byte, nibbles, words. Although the most common that you're going to use is bit and byte, but still you're going to also apply some time on the nibbles and words. So please make sure how many words that represents how many words if you want to have bits. So let's say one word is equal to byte. If you have one word is equal to 16 bits, or it is a nibbles, it's going to be 4 nibbles equal to one word. So you need to know all. That's why how many bits is easy for you to remember. The bits in byte are normally numbers from 0 to 7. Byte. You're going to number from 0 to 7. Of course, we're going to play from from right to the left. In here, we have altogether 8. It's going to be equal as 1 byte, having 8 bits. So bit 0 is the low order bits, which is the rightmost, and the the least significant bit LSB over here. And we already know this part. And for 7 is the higher order bits, which is the leftmost, and it's also known as MSB, most significant bits of the bytes. This is referred for 1 byte. Not 1 byte also contain exactly 2 nibbles. So you can see this is 1 nibbles, this is another 1 nibbles. So you have, let's say for 1 byte, what you have inside, you're going to have 8 bits, but you also have contain 2 nibbles for 1 byte. If let's say for 4 bits, you can see over here you have 0, 1, 2, 3. As long as it is 4 bits. And major use for this kind of coding and the nibbles, you're going to apply into your BCD or binary, coded, decimal, or hexa numbering. Because you play around hexa numbering for 4 bits, right? So hope that everything is okay for you to memorize these bit nibbles by words. Okay, there is an example over here because this one we just also look into. This one, if you want to convert from binary to hexadecimal, you will get F. 1011, you will get B. And this one will be 7. So you can calculate it by yourself. Okay, for this one, it's quite similar to at the back, which is 8 bytes, 1 bytes, and also equal to 8 bits. And total value that you can have, the maximum is 256. But for Nibble, the maximum number will be 1111, which is F for 16. Or this one is equal to, in hexadecimal, 8 plus 4, 12, 15 also. So this is maximum number for Nibble. And the maximum for number for byte will be 256. And measure use numeric number 0 until 2 the power of 8 to minus 1 equal to 255. And the value is 256 is total or including the 0. That's why you can see over here. Okay, the range for nibbles, you can have the value of 0, which is, this is 000, until the maximum you will get 1111. And this value will be 15. Best 10, of course. This one is, I talk about value. So this is maximum, and total number will be 16. That will cover, which is you have 000, 00001, 1, and then 0100, and etc. until you get 1111. This one also we already looked into last time. I give you a sample, right? Same goes to byte. You're going to have the range of here 256. Why? Because you have to the power of 8. As mentioned previously, if you have 3, you're going to have a possibility of to the power of 3, going to get 8 possibility of numbers. Situation. If you still remember when we look into gates, if you have two input, you're going to have to the power of 2. There is will be only 4 possibility. If you have 3 input, you have to the power of 3 will be 8 possibility. If you have 4 input for your gates, you're going to get how much? 16 or 32. I forgot already, see. And you can see that it is depend on how many input you have and how many bits you have. Similar to here, if you have to the power of 8, you have these possibilities on number, but the range will be 0 until to the power of whatever numbers that you have here, minus 1. Then this is your range. If let's say for 2 the power of 3, which is you're going to have 0 until 7, altogether you will get 8 possibilities of 8 numbers inside. That's why this will be 0 until 2, 3 minus 1. This is the value of 7. And for sign numbers, what is positive possibilities numbers that you're going to get? You will have from -1 to 8, 2 plus 1 to 7, positive 1 to 7, if you have this range of sign numbers. Later on, we will look deeper on signs numbers because you're going to learn first complement, second complement. So this is when you want to apply the sign number, but it is later on we're going to touch in deeper. Let's say, okay, another one is for word. Going to see over here. We have all together, let's say 16 bytes equal to 2 bytes. 16 bit equal to 2 bytes. But bit 0 to 15. Total value you have to the power of 16, which is these numbers of value. You have 0 until 15 all together. Major use of words, which is this is for signed integer when you play around with signed numbers, and for unsigned you're going to have 0 until the value of this minus 1. Normally it's going to use the Unicode characters, but we basically didn't touch Unicode characters too deep. But as long you can see over here, you have also a code in numbering system. You not just play around with 1, 0, 2 until which is 0 until 9, which is numbers, but you can see also that you have a code. Especially like when you play around with hexadecimal, right? You also have A until F. So this is like representation of the codes. So code is representations of information generated by following rules. So in general, we need code because it is unique, easy to process, easy to representation. Code enable communication in place. Okay, I give you very easy example, which is UTM. So UTM, you know what is representation? It's like a short form or a code. Then is U is university, T is technology, M is Malaysia. So it is just a code or maybe a short form for you to remember or to represent something. Due to this, code can simplify the process such as manipulations, arithmetic operation, and informations in digital system. And when you play around with programming, for those who learn programming, you will notice that normally you're going to use a short form. If let's say you want to move any value, especially when you play around with assembly language later on, which is the very basic programming, before you can go high programming language, which is like C. C is also not the best, the basic programming, because our basic programming is assembly language. Before you going to go higher, it's better for you to learn assembly language first, because you're going to learn hierarchy in here, then easy for you to learn C, C++, Java, Python, and etc. So for the basic programming like assembly language, you're going to use, let's say you want to move a value or whatever you want to move inside your computer, you normally use like MOV instead of move. And additional, let's say you want to add 7 with 9, you did not like have a long additions and so on, you just use 8. Subtraction, multiplication, everything will be in short form. That's why it's like a code for a computer to know something instruction that we provide. And in numbering system, there is a several code language maybe that you need to know, which is BCD codes, gray codes, ASCII code, and parity codes or bit. BCD or binary coded decimal is slightly easy for you because you are familiar with binary, you also familiar with decimal. Later on when you go for like gray code, ASCII code, you need to have their own tables to like convert or representing anything on this. But for binary to decimals, it is not very hard for you. Uh, there are only 10 code groups in BCD number, one for every digit, which is 0000 until 1001. You please notice over here, please take notes that you're going to start with 0. Ada kelas. You're going to start with 0. Then you can see over here, you will start that this is the maximum number you have, which is 1001. There is no continue, which is 1010 and etc. So all the number from BCD, which is only from 0000 until 1001. So my students just knocked me and then but I already informed them that I have class. Okay. If you have this part and the rest is going to be like invalid number for BCD. You cannot represent it. You will have like decimal, but BCD, decimal, BCD. For here, you can see you have 0 until 9. Why? Because you want to have like binary to decimal, you have only 10, including 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See over here, you have 10 code. And the value will be on BCD 0000 and then 0001. Oh, student saya nak ajak anak saya pergi sembahyang kot. Sekejap Okay, then you're going to see that you have 0000, 0001, 0010. So this is all like a normal representation, but until here only, which is 9 is the maximum. And you cannot have 10, which is 1010. Abang, ikut abang dengan kakak tadi pergi sembahyang dulu. Cakap kat dia orang pergi surau je tau, jangan pergi masjid. Jangan pergi masjid. Masjid jauh sangat. Okay. So invalid code. Tunggu dia orang datang dulu. Invalid codes are 1010, 1011, 1100, 1101 until 1111. This is all invalid code for your BCD. So example 1, if you want to convert, you can see if let's say you have this value which is 3245. This one is your normal decimal number, but when you want to convert for BCD, you're going to see that you will convert one by one. This will be 5, this will be 4, this will be 2, this will be 1. So when you convert, you get 0011, 0010, 0100, 0101. And if you have another example, you have 7848 to BCD. Then you have 0111 and etc. You can see over here the example. So that is on BCD. It's slightly similar to your conversion for binary, but you're going to see it will be divided into 4 and you will have the invalid value, this one, for BCD. So it's what like some although it is like very easy for you to do these conversions of numbers, but it's slightly confusing you because it's look like similar, right? Okay, before we proceed, let us finish until ASCII first. Curi masa you sekejap, okay? Yang pergi tengok kakak tu dah kat luar ke belum? Jangan lama-lama sembahyang pandai di kelas. Grey codes, you can see designed to prevent pergi solat tak? Grey codes, you can see designed to prevent false output from electromagnetic switches, and it is widely used to facilitate error corrections in digital communications. Who did turn on their webcam? No,
It's
microphone.
Ahnaf.
What again?
Someone not
Yeah.
unmuted their mics. Yeah, now it's muted again. Don't worry.
Hello? Okay, testing. Okay, now let me finish a little more bit until ASCII. So this is gray code, and this is the purpose for you to use the gray code. I think you can read this part. And normally we're going to play around with electromagnetic switches. This is the one that you're going to apply inside when you do the programming. And there is a conversions way for you to convert gray code to binary. How are you going to convert binary to gray codes? This is like equation for you, which is for binary number, while the GG things over here is the gray code. You can see that is a G, which is represent as the gray codes. And for the binary, you're going to see you will like adding this number to the slightly one place to the left. Later on, you're going to see how we're going to get the gray code. To convert the gray code to binary, if first proceedings once, if let's say you have the value of first proceedings G is even, if no ones, which is digit 1, precedings G is odd. So there is a hint for you whether it is going to be an evens or an odd number. Let's take a look into this example. Am I log out from here? No, right. Convert this 100110 to equivalent gray code value. So you're going to have this table. Let's say first you have the value of binary. This is all binary. You're going to convert to gray codes. So you will bring your MSP down. This one is might confuse you, so that's why I show this. Going to maintain your gray code for B, for 1 here, and you will adding. See, you will add 1 plus 1, and then you will get the value 1 plus 0. You will get the value of 1. Also, you will put 1. Again, I repeat. Let's say you have value 10011010. You will get this one to be at the first MSB for your gray code. And then this value, you will add the total numbers that you add this one, you will bring to your gray code table. Similar to after that, you will add 0 plus 0. You will get 0. And then this one, 0 plus 1. You will get 1. 1 plus 1. You will get 1 also. And you will have a carry. Why? As I mentioned, you will have 0 plus 0, you will get 0. 0 plus 1, you will get 1. 1 plus 0, you will get 1. But you will get 1 plus 1, you will have 1, 0. As I mentioned, this is your answer. And this is the carry. You still remember? This is your carry. And in this gray code, you're going to see you will tag the answer here to be at the gray code, and you will discharge the carry value first. And you will continue 1 plus 0, you will get 1, 0 plus 1, you will get 1, and 1 plus 0, you will get 1 also. So please take note, if let's say you have scenario of 1 plus 1, of course, you will get 1, 0. And this one is your answer, but this carry, the value of carry, you will discharge. So then you will get 0 for your gray code. So in terms of the answer, you will like having the answer 110101111 for your gray code when you want to convert. Another example, convert gray codes to binary. Now it's vice versa. Just now is you have like a binary to gray code, right? Now you need to have vice versa, so it's slightly different. Let's take a look how we're going to do this. Okay, as usual, first of all, we're going to maintain our MSB. We will take, but instead of we like adding this time, but now we're going to do like a zigzag things. Let's take a look. Okay, uh, you will do drag the MSB, and this value you will add with the value of your gray code. Now your value will be 1 plus 1. It is not like this anymore, okay? For binary to gray code, you're going to do like this, which is you will add all the binary numbers. But for the gray code, you're going to do zigzag adding. So you're going to add the value of binary, you will add with the gray code. And now your value will be 1 plus 1. 1 plus 1, I already mentioned it will be 1, 0. So this is your answer and this is your carry. And you're going to discharge your carry over here. This is your answer. Now you're going to see 0 plus 0. You will get 0. And you will do the same. 0 plus 1, you will get 1. 1 plus 0, you will get 1. Now you have a similar scenario, which is 1 plus 1 again. So you will get 0 and you will discharge again the carry. 0 plus 1, you will get 1. 1 plus 1, again, you have 0 and you will discharge your carry. Allah Akbar. How to mute? Okay. So that is on the conversion for binary to gray code and gray code for binary. It's not too hard for you. Just slightly maybe it's going to, you need to remember how you're going to play around with the adding things. Whether it's like direct adding numbers between binary or you need to do like a zigzag adding over here. That's why I don't want to show you these first pages because me myself also will like very confused to do this. That's why it's good for me to just show you the example for this one and another example, because it's like slightly easy for you to remember. Only you need to remember, as I mentioned, 1 plus 1, it will be 1 0. In decimal, it will be 2, isn't it? But this one is carry. This is your sum for binary. And I think I don't want to take longer. I cannot finish until ASCII. We will continue again in our next class tomorrow. We will look into parity, odd and even. And then we will go to also first complement, second complement. That is all numbering, which is more interested rather than you need to learn on history. Okay, any question? No question. So, I dekat beach sekarang ni. Kat mana Langkawi. uh, saya dah fly sampai ke Langkawi dah. Sangat-sangat memerlukan cuti ni. So I think before you end up our class, please make sure you check back the QR code, whether you already scan your QR code or not. Then for those who still not finish your Jamboard, please do so. And I think there is nothing more. Just please stay safe at home and meet again tomorrow, okay? Anything you can just WhatsApp me. Please also WhatsApp me who those who did not get your e-books and also your hard copy module. Okay? Bye-bye.
Thank you. Thank
Doctor.
you,
See
Doctor.
you
Bye.
next time.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Doktor,
Yes.
saya ada soalan. Kalau